Next speaker is going to be Asko Soukko. He's coming from University of Jyväskylä and he's talking about robot framework in Plone CMS project. So, welcome Asko.
Thank you, it's great to be here and it's my pleasure to start the second session today. So, as was mentioned, my name is Asko Soukko. I come from Jyväskylä, which is a middle-sized town, 3-hour drive north up from here. And I work in our IT service of our university in a small development team. I work as a senior Python and full-stack developer. And why I came here to tell you, I also am a core contributor in open source CMS project, content management system project called Plone. And why I came to tell you how we successfully adopted Plone robot framework for acceptance testing in Plone community for the core Plone project and also for the add-ons and many also for the private stuff. And how I know we were successful in adopting that in a few years? Well, it changed our language how we talk about testing. Before robot, we might have argued about is this test functional or acceptance or whatever is the right name for that. But nowadays, we only talk about robot testing. We have robot tests, so we don't have acceptance tests anymore so much. But whenever we talk about Selenium acceptance testing, we talk about robot testing and robot tests and robot stuff. So let's start from summary. So the robot testing ended up becoming a norm in our community. So whenever we write tests for Selenium for testing features in acceptance test through browser, we do them through robot framework and with Selenium. And once we got that done, we wondered if there is any other stuff those robots could do for us. And we figured out maybe they could help us to automate our screenshots in our documentation. And I think we also succeed in that. And I'll tell about that later. And also, while we were doing this, of course, we had to develop a few add-on packages and libraries and stuff for robot framework. So we did those, and those are all open source. I will review a few of them during my talk. And also, once our community learned to use robot framework, of course, they also wanted to use it for other projects and Plone-related projects. And they also happened to write a few libraries for other frameworks. And to keep us on the same page, some scope for the talk. So yes, we use robot framework with Selenium library only. Currently, we are using Selenium 2 library. And of course, we need to migrate for the new Selenium 3 version. Of course, there are that backport for, so we don't need to hurry about that. And yes, we are only using it for Selenium acceptance testing. We have other frameworks for the existing framework, older frameworks for the other tests. And we are using only the plain text robot framework. And we choose to prefer the PDD, behavior-driven development syntax, for the robot framework tests, plain text syntax. That tests that start with words given something. When I do something, then something happens. And why we choose that? We choose that because we liked how it helped us to think about testing. Because it clearly helped us to separate the things that happen before the tested thing, that given clauses, and what happens during what are we testing, the when clauses, and then the assert that check that was the test successful or failure, that then clauses. So we think this PDD syntax help us to make better tests. So what is Plone? Plone is a content management system. It's open source. It's written in Python, and we call it Enterprise CMS because it requires some resources to be run. It's not efficient to run for very small sites unless you can run a lot of small sites in one server. So we focus on enterprise. It's good for intranets or public websites, knowledge bases, and stuff where a lot of users, a lot of hierarchical content, deep hierarchies, maybe complex access control rules requirements. So those are the areas that Plone shine. It's quite old. The first version was in 2001, so it predates robot frameworks and many other stuff and libraries. And And it started when Python was still very quite one young language, and that still affects how things work there. And Plone is built on top of we call component architecture, which shows in that when you install Plone CMS default installation with Python, it's made of 2,255 Python packages at least. So of course that's nothing when you compare it to Node.js project, but it's still something in Python world. And when we talk about testing Plone, there is no single Plone we are testing, but we need to build a framework of stuff and you can test any kind of combination of all the existing packages. We really need to kind of framework on top of framework to be able to test it. And some unique features or very Plone-ish features are that Plone has been from the very beginning. It has one right team content management. It tries to show the editing interface very similar to the final viewing interface, so it stays the same. And yeah, it's also known it's very good security track records. Some 3-letter agencies in US use it because of that. That's Plone. And that's my university. We are using Plone for all of our websites. And that's why how I became to work with Plone and still work it. So let's get started. How we came to be and use robot framework. That started in 2011 at San Francisco Plone conference in San Francisco, and we realized that our current frontend had failed. We are seeing a crisis in front of us, and we need to reinvent our frontend. And we had almost full acceptance test for our frontend. That really also tested JavaScript parts. We had a few generator Cilium tests, but those were completely unmaintainable. So at that conference, Robot Framework was introduced. Actually, it's funny that I had to travel to San Francisco to hear about Robot Framework, but it did its job. I learned it. And then also Ed Manala was there, and before the conference, I was very skeptical about Selenium. I had bad experiences of that, but Ed managed to convince me and show me how to use it, and it convinced me that the next version, the WebDriver-based version, will be better, and the Selenium 2 library will be better than the existing ones. And then we all got back home, and it took time to think about things. And next summer, I had trainees at the university. I was leaving for a month holiday to Asia, and I want to make sure that we have some kind of quality control for the stuff that trainee does. So that gave me a time to make first integration for Robot Framework. And we were using not Plone for that project, it was Pyramid-based Python framework, but used the same core Python unit test library. And so I developed Python unit test integration for Robot Framework so that we could wrap Robot Framework test into Python unit test so that we can run it with other test runners. So we didn't start with the robot command, but we did start with using our existing test runners, run those tests. And at the same time, the same guy who presented Robot Framework at San Francisco conference, Godefroy Chapel from France, so he also started writing first common keyword library for Plone, how we start Plone test fixture from robot tests, and how we log in and how we test some common stuff. So when the year got on, I also managed to try my stuff on Plone and write some integrated blog post of that, how you can get started. And once the next Plone conference came in 2012 at Arnhem, Arnhem, Holland, or Netherlands, so suddenly everyone was kind of interested. Are you the robot guy? How can we use that stuff? And after every Plone conference, we have like 2 days coding sprint related to Plone. I think I spent the whole coding sprint for teaching people how to getting started with Robot Framework. So after this year, we kind of knew all the people who were very interested in the framework stuff, and the next year, things started to get forward faster. So very early, 2013, we had a dedicated sprint for coding sprint for just building and testing tools. That was in Barcelona. in Catalonia. It was fun. And there we reviewed what we had done the previous year. We wrote, I called it opinionated Plone-specific integration package on top of that, our unit test wrapper package. And that was important because it kind of defined the common practice how we will continue to use robot framework with Plone and made it easier. And on top of that package, we could integrate it to all our templating tools. So usually when you work with framework, you develop add-ons on top of that. You need to have that on the framework providers want to provide you some kind of scaffolding templates how you get easily started with new add-ons, new product on top of that framework. So we integrated robot framework examples into that template. And after that, every time when someone created a new project, new add-on for Plone, it already included some basic robot framework tests. Maybe it's just open Plone and so everything worked after your add-on was installed. But it was there, and it was runnable with the other tests. So there was like no overhead for getting your first robot test run for a new project. And also we write better documentation, like in narrative from how you easily get it started. And training at the sprint continued. So whenever I went in that year or a couple of years after that, I was usually the guy that everyone asked about robot framework questions. And that was a weird period, like how I came to be that it felt strange. But anyway, we discussed it, I helped people, and they helped again other people, and the information spread. And that year ended with we building a Sphinx integration for robot framework. I mean, I thought we started discussing what could those robots do next for us, and could we generate screenshots in our documentation. And that introduced a few packages that helped for that. One of them was Sphinx integration, so that we can write inline robot framework scripts in the Sphinx documentation. Sphinx is the documentation builder written in Python. It's based on a restructured text called text format. It's very popular in Python projects. It's also having popularity in the outside Python world. So that made it possible to write like inline screenshot capturing scripts inside the documentation, so that when you compile the documentation, you have the screenshots there. Of course, it's very technical. When you have a small technical team writing documentation, also while developing, then it's neat to use. And this is a very dark picture of our team at the Barcelona testing sprint. And that's because when we review what are these sprints I'm talking about. So I'm talking about code sprints where we gather a few people, maybe from 10 to 50 people, for a couple of days or a week, develop on stuff on some open source product. Because Plone is very distributed. Why it's interesting how we succeed to use robot framework in Plone is that Plone is a very distributed community. There is no central owner for Plone CMS. There's no one company behind that, but it's Plone CMS framework code is owned by Plone Foundation, and Plone Foundation is made by its members, and its members are individuals working in companies or universities that have worked on Plone. So there's no single developer making Plone, and whenever they need something for Plone, they develop their features on their own. But when there's something bigger that needs more coordination, then they call a sprint. They want to organize a sprint. They reserve a time and place and make invitations. And somehow people just come all around the world, mostly in Europe and US, and some people on other continents. But people come the same place for a whole week, enjoying together and working on some topic. And when you go to Wikipedia, this way of working was pioneered by Soap Corporation in early 2000. And because Plone is built on top of a Soap application server made by that nowadays no more existing Soap Corporation. And many of the developers knew each other very well. We also participated in Soap sprints. We kind of inherited the Soap community sprinting culture, or Soap Corporation sprinting culture in the Plone community. So after like a few years, we needed to adopt the robot framework, and then come to nowadays. Now we have in the core Plone, when I did the GitHub search mainly, there is 85 robot test suites for the core Plone, each of those containing a few tests. And then we had more than 100 generated screenshots in the documentation. And what we call collective is we have GitHub organization called Collective for all the non-core Plone code. The core Plone code is owned by Plone Foundation, but the rest of the code that is made for companies for their add-ons which they want to open source and let others to use it and others to contribute it, we have a collective called organization in GitHub. The idea is that anyone can join the collective without any legal work and can share their code so that everyone can contribute easily to make the contribution barrier very low. Because in the Plone core, we need to be legally very safe. We need to make sure that everyone signs contributor agreements, that all the code in there are really owned by Plone Foundation. No one can buy Plone out. And anyone can use that code safely. So we call it collective. And when I did search there, we had more than 200 robot test suites. Well, some of them are, of course, only those first tests you get when you generate a new add-on, new project. But even that's something, because it's run and it's tests that it's a smoke test that the add-on works. But it's also a template where you can add more tests easily. And of course, as I said, there are strong adoption in private projects. Of course, I use it, other developers use it. Last Plone conference, there's Dresden Technical University was having presentation where they showed they had taken in practice that they test all their features mainly with access time test in robot framework. Of course, they are top-level tests, so they know they don't catch. They catch almost everything. They don't always tell what the real reason is, but that's they needed to smoke test that it works. So they had to practice on that, and they had hundreds of tests running every day. And we have some more numbers and scope. So this is a screenshot from Plone Jenkins. So we have like almost 9,000 tests in total in Plone, and only more than 100 those are robot tests, but those are all Selenium acceptance tests. So those are also quite slow tests because of that. So we kind of try to keep this test running fast by choosing when we really need Selenium testing. So mainly when we need to test JavaScript requirement features, then we use Selenium testing. And we test every pull request, every feature added in any of those Plone core packages. And that was one of the stuff that started at the Barcelona sprint in 2012. So now, if we have a pull request for any of those 250 packages in our GitHub Plone organization, we can create a pull request that tests a Jenkins job that tests that pull request against all the other packages. So that has been a lot of work, but now it's nice and it makes it safer for us to make new features in that insane environment of hundreds of packages. So, how did we success? So we started with a quite good base. We had a good existing testing framework on Plone that already managed that complexity of those hundreds of packages. And thanks to that, we only needed to add a wrapper to call robot with the test fixture with all those packages activated. That made it easier. So we made it easy to use packaging of that, and then we bundled with our scaffolding tools so that everyone gets starting fast, the robot framework. We write narrative blog posts and documentation how to use that. And because we wrote those, I wrote most of those in long time period, like 1 month or so, the topic were current for a long time, so many people read that and get known to the topic. And then we trained other developers at the sprints and conferences. So maybe even if I and Ed were the first change agents, then we trained more change agents, and the idea of using robot framework spread organically, like was shown in previous talks. And of course, the key is to be nice. So whenever someone came or still comes to ask me about robot framework, I help them and try to help them nicely and see that they got their issue solved. So it keeps us good. It makes us feel good, yeah. So, of course, we had issues. These are very familiar to, I guess, anyone using the Selenium. So, I don't recall many complaints about the robot framework at all. Of course, some complained that why we need to learn one more language. But when they started using robot framework, they kind of realized that it has enough power to make that reason. So the real issues was it's way too easy to make timing issues when you do write Selenium tests. If you don't write good tests in the beginning, make good asserts, or wait until something happens properly, then you get timing issues and you get flickering tests. That's not nice. And the instability of Selenium ecosystem itself. If you have been testing with Firefox and Selenium for the last few years, and you try to use the latest version, you have to always match that you have the right Selenium version or the right Firefox version, then you have the right Gecko driver version to get everything working. That has been quite a hassle. I hope it stables now that Firefox Quantum is out. And the main robot framework issue has been that it's too easy to use a double space separator in our plain text test suite, so it's too easy to forget that, and then test fails. And when we started, there was not that robot framework linter yet, and we haven't integrated that yet. So that has caused, I guess, we have a lot of variation in our tests quality, because we only had good reference tests way later than we started teaching people. So maybe we should have first think about the really good test examples and then start teaching people. It would have got better. So I have some time go through the libraries we made that are available as open source. First one is Robot Suite. It's in Python, available at PyPy. So it's the one that wrapped a robot test suite for Python unit test. If you still use some Python test runner that uses unit test suite, then that could be usable. It was inspired by dog tests. Suite wrapper in Python core, standard libraries. It works very much similarly. And what it does, it makes that robot framework test suite, and it makes every test in the test suite separate, completely separate, calls robot framework separately. And that worked for us well because it made our current framework handle the test isolation properly. So really each test was running isolated environment. So in Plone, we have used Soap test runner, and that provides our layers that config the build, starts the Plone sites, starts the add-ons we want, and then we call robot framework to do the actual testing. Then was our dedicated library, and I think the best ideas in there was we need to create one keyword for opening the Selenium test browser on top of the Selenium library default keyword. That was so we could parameterize it with environment variables and make it possible to run the same test in any environment. You could run it locally, you could run it on CI, similarly in parallel, because you could give a different port and stuff for every test running in parallel in different Jenkins jobs. Or you could use source labs, all without making any change for the test itself, just parameterizing the running environment. And then we really love the remote library in the robot framework. We invented a way because we want to be able to run the Plone process separately, also from the actual test runner, and making all the changes to the test fixture of the test site only through Selenium is slow usually. If you remember those given when then keywords, you're given some folder and some page and some situation, then something happens. If you have to implement those given keywords in Selenium, it takes a lot of time. So we write a remote library that we can call directly with RPC from the robot framework, and that sets up those given clauses. And then we only use Selenium for the then clauses. And that was one trick to make our test faster. And then we implemented on top of that remote server that can reset the fixture also remotely, so we can make a test isolation work correctly. And it also includes those normal user keywords that any custom library includes for that specific framework. And then we want to make the screenshots. And while Selenium2 library already includes that capture page screenshot keyword, but it's not usable for documentation, which always captures the whole page. So we implement on top of a jQuery library that can take a file name and then list of selectors, and it calculates the bounding box of the selectors and then crops the image. And it also includes some other keywords like making small changes for style so we can hide stuff and highlight stuff. And this is one example for our test. So there we have had some navigation. Before test, this is a feature where you can check out the page. We call it working copy. You have published the page and you want to edit that page without affecting the published page. You make a working copy of the page, work on that, and then publish, then it overrides the existing page. And so we make those features in Selenium beforehand, and then we take a picture and crop it, and include it in documentation. And there is visible, this is the actual code just taking the text screenshots. So we can make it like localizable, so that we look at it translates where it should go in current language, and then goes to hide some element, and then finally captures the screenshots. And this is another example from my in-house project in a university. So we have highlighted the button that the users should click next. Of course, these are quite technical to write for real document writers, but we use this to make easier to discuss with the customer during the development phase. So when we create this screenshot on every commit, we can get faster response from the customer who can check the documentation and see how all the different branches of the user interface work. And finally, there's the Sphinx extension that allows to write inline robot framework code so that when you run Sphinx build in the documentation, it takes the screenshot and then includes it with the default figure directory in docutils.
2 minutes.
Yes. And when you integrate this with like CI, like Travis, and publish every build to S3, you get like a time lapse of the evolvement of your user interface. So it's fun to see afterwards how has some certain interface developed during time. Here in middle, we changed from Plone 4 to Plone 5, and the complete interface gets a little refresh. Here. It's a nice extra feature, go back in time. And finally, to see how it works for internationalization, the small video I made where I go through every localization of Plone and capture the front page. And so with only having one code to make one screenshot, I can make that screenshot for every language we have available when we support, without making any changes for the tests. And I mentioned there are also other robot framework libraries made by the people who learned robot framework during Plone. There are a similar wrapper for Pyramid. And then there are you'll see these libraries for the other frameworks. They have maybe only a few keywords, but they have get started using robot framework with those libraries. And also, I did some experiments with automating acceptance tests, but those got outdated when the Firefox Quantum came that disabled the old Firefox extensions I was using. So that's it. I was in time.
All right. Thank you very much.